Hello, my amazing math students. This is Mrs. A, and I love math. Tonight we're doing lesson 79 in our Saxon Orange Book, Systems of Equations with Subscripted Variables. Now, sometimes it is useful to have subscripted variables, especially when we may be talking about two people in a problem instead of just one. So, for example, this could be the rate of Abby as opposed to the rate of Peter, the time of Abby as opposed to the time of Peter. And so when we have two people or two different quantities that we're talking about, sometimes it's just easy to use subscripted variables. So here we're going to solve this system of equations for RA. And this is not difficult at all because they give us RP and they give us TP and they give us TA. They give us a lot. And all we have to do is find RA. That's pretty easy. Okay, so all we're going to do is take RA, which we're looking for, and we're going to substitute in all of the other variables they give us. So TA is 3, plus RP is 50, plus times TP is 4, is 320. Okay, so we're trying to find this unknown quantity RA. The first thing we want to do is get rid of this right here. So we're going to subtract 200. So subtract 200 from the left and subtract 200 from the right. So now we have 3RA. R sub A is how we read that. And then the 200s go out. 50 times 4 is 200 minus the 200. And then 320 minus the 200 is 120. So we get 3 times RA is 120. We divide by the extra 3 that we don't want there on both sides. And R sub A is 40. So R sub A is 40. And that's all we have to do to solve for a subscripted variable. So a subscripted variable is nothing special. It's just a variable that has a name that distinguishes it from another like variable, like two different rates of two different people. So rate sub A could be Abby's rate, and rate sub P could be Peter's rate. And we can keep them separate without having to write down Abby's rate and Peter's rate. So here's another example with subscripted variables. R sub t times t sub t plus 120 is R sub r times t sub r. Well, we already know that R sub t is 2 and R sub r is, well, I didn't write that very well. What is it? R sub r is 10. And t sub t is equal to t sub r. So they did not give us a number there, but they did give us a piece of information that will be helpful in doing that. So now R sub t is 2. So we're going to put the 2 right here where the R sub t is. The t sub t is the same as the t sub r. Since I don't want two variables that are unknown, I'm just going to put t sub r right here. And we're just going to make all the t sub t's equal to t sub r. So when we solve for one, we've already solved for the other. Plus 120 equals R sub r, which is 10, t sub r, which we don't know, but we know enough to solve, don't we? So we have 120 on one side. We've got a 2tr and a 10tr. Let's get all the TRs on the right. So minus 2tr. Minus 2tr. So when we do that, we end up with 120 equals 8tr. So let's put that right here. 120 equals 8 t sub r. Divide both sides by 8, And we get t sub r by itself. So t sub r equals, and 120 divided by 8 is going to go 145, 15. Okay, so t sub r is 15. That means t sub t is also 15. So t sub t is also 15. And that's pretty easy to do. All right, can you see that? Just substituting choosing which one we're going to put in, t sub t or t sub r, so we only have one variable is the key to doing that. Then when we solve for one, we have both, don't we? So this is example 3, and we're talking about a little brother and sis. Okay, so we're supposed to solve for time of little brother and time of sis, and they're taking a trip. So the rate of little brother times the time of little brother is equal to the rate of sis times the time of sis. They're giving us this. The rate of little brother is 40. The rate of sis is 80. So she's going twice as fast as little brother. Okay, and the time of sis is the time of little brother minus 5. So we have our information. We're going to solve for both times. And when we're looking for this, we could use a substitution. You see, we have TS is equal to TL minus 5. And here we have a TS. Okay, so let's put this TS up here by substituting TL minus 5. We're given the two rates. So then we'll only have one variable to solve for. So rate L is 40. TL, we're going to keep the TL variable. So we're just going to put TL there, equals rate S, rate of sis is 80, times TS, but TS is TL minus 5. So we're going to replace TL minus 5. All right, so now we have 40L, 40TL, equals 80 T sub L minus 80 times 5 is 400. Okay, so we want to get all of our variables on one side. So let's minus 80 T sub L minus 80 T sub L. So we end up with a negative 40 T sub L equals negative 400. All right, well, look at that. Negative 40 T sub L equals negative 400. Doesn't T sub L have to be 10 to make that true? So T sub L is 10. Well, if T sub L is 10, 10 minus 5 is 5. So time of sis is 5. So it takes her 5 minutes, hours. They didn't really say in the problem. It takes her half the time because she's going double the speed. Look at those. Yeah, pretty soon we got one more example, and then you get to do some by yourself. Last example here. So R sub F and R sub E are the ones that we're trying to find. R sub F times time of F. So rate of F times time of F is equal to rate of E times time of E. Time of F is equal to 16. Time of E is equal to 12. R sub E equals R sub F plus 15. So since this is easy to substitute this in, let's keep the R sub E let's substitute the R sub E and keep the R sub F. So we're going to substitute the R sub E. So here we go. R sub F, we're going to keep. So R sub F. T sub F is 16. R sub E, we're going to substitute with R sub F plus 15. But I'm going to put that in a parenthesis so I don't forget that it's all together. T sub e is 12. Okay, so here's my equation. R sub f times 16 is equal to R sub f plus 15 times 12. So R sub f is 16, R sub f equals 12 times R sub f plus 15 times 12. What is 15 times 12? 15 times 2 is 30. 15, 180. Okay, so now let's get all of our R sub f's on one side. So let's minus 12 R sub f minus 12 R sub f. 4 R sub f equals 180. Okay, so 180 divided by 4 is 45. So R sub f is 45. Now, can we take R sub f and go back and find R sub e? 45 plus 15 is 60. So R sub e is 60. Those are kind of fun. Now we're ready to do our practice problems. All right, so here we are with our first practice problem. So copy it all down, and then I want you to go and do it on your own, and then turn this back on and see. R sub a times T sub a plus R sub p times T sub p is 460. But R sub p is 50, T sub a is 2, and T sub p is 4. So this is pretty simple, right? They give you 3 of the things and you have to find the 4th one. Okay, so R sub a is what we're trying to find. So we'll keep R sub a there. T sub a is 2. Oops, plus R sub p is 50. T sub p is 4. We're multiplying those, equals 460. So R sub a times 2 is twice R sub a plus 200 equals 460. Okay, so now let's get rid of the 200 by subtracting 200 from both sides. Twice R sub a equals 260. So all we have to do is divide both sides by 2, and we get R sub a is 130. Now, let's check. We haven't checked. R sub a is 130. So R sub a times T sub a was 2. So 130 times 2 is 260. And then R sub p is 50. T sub p is 4. 50 times 4 is 200. 200 added to the 260 is 460. And it works. I love it when it works. One more practice. Here is our last practice problem. So copy it down and then go find T sub r and T sub t on your own. Then come back and check it. So let's read it. R sub t times T sub t plus 200 is R sub r times T sub r. R sub t equals 10. R sub r equals 15. T sub r equals T sub t plus 10. Find T sub r and T sub t. Now pause your video. Hopefully you did that. Let's go ahead and see what we have. So basically I'm going to copy this down and then substitute. So since we have T sub r is t sub t plus 10, we're going to sub out the t sub r with this. Okay, so we're going to end up keeping this one and subbing this one out with this. So r sub t is 10. T sub t we're going to keep. Plus 200 equals r sub r, which is 15. T sub r, which we're going to pull out the t sub r and put t sub t plus 10. Now, we have one equation and one unknown, which means it's solvable, right? So 10 t sub t plus 200 equals 15. We have to distribute here. 15 t sub t plus 15 times 10 is 150. So now let's get all of our t's on one side and all of our numbers on the other. Since this one's bigger than this one, why don't we get minus 10 t sub t minus 10 t sub t. Let's do that first. This goes away, and we get 200 equals 5 t sub t plus 150. So now we want to get rid of this 150, so we get the t variable by itself. Minus 150 minus 150. 50 equals 5 t sub t. So isn't t sub t equal to 10? We divide by 5 over here and divide by 5 over there, and we get 10. So t sub t is 10. All right, so now we have to go back up here. T sub t is 10. So isn't t sub r 20? T sub r is 20. Because it's 10 plus 10. Now, let's go ahead and check it. So let's go back all the way up to the top. R sub t is 10. T sub t is 10. R sub r is 15. T sub r is 20. 10 times 10 is 100. 100 plus 200 is 300. 15 times 200 is 300. And it works. We get 300 equals 300. And we are done with the lesson on systems of equations with subscripted variables. And I hope you have enjoyed this. And this is Mrs. A. And may God bless your day.